In this example, I need to use the graph of each function to identify its domain and range. Here is the first example here. Here's our graph. It's very important on these problems that you look at the end of the graph, whether it ends in open circles, solid circles, or arrows. If you have an arrow on the end, that indicates that this graph keeps going up and out to the left. And this one, it's going to keep going up and out to the right. Remember, the domain are the x values. So is there going to be a graph out here as x approaches? Remember, in this direction, x is going to approach negative infinity. Is there anything stopping the graph going out there? No, because it's just going to keep going up and out to the left. So my domain is going to start at negative infinity. And then as my x values come in, I have a graph, and now as x gets bigger and bigger, the graph is going to keep going up and out. So my domain is going to approach, remember in this direction, x approaches positive infinity. So there's no restrictions on the domain. The graph goes from negative infinity to positive infinity in the x direction. Now we need to look at the range. Remember that are the y values. Is there a graph down here? No, there's no graph down here. What's the smallest y value we get to? It's right here. So it is at -2, and there is a point where y equals -2. So I'm going to have a square bracket at -2. Comma, now where's this graph go in the y direction? Does it keep going up? Yes, it's going to approach positive infinity. And remember, with infinity and negative infinity, you always have to use parentheses. Now let's look at example 2. Notice I don't have any arrows on the end of this line. So now to find my domain. Remember, domain are the x values. Is there a graph over here? No. What's the smallest x value I hit as I come in from negative infinity? It's right here. So since this is -2, that is -4. That point I'm interested in is -3. But do I include the -3? No, because it's an open circle. It doesn't include the -3. And my x values keep going. My graph keeps going to this point. And what's its x value? It is right there. And so that is +5. Do I include the 5? Yes, there's a point where x equals +5. So my domain is parentheses -3, 5 with a square bracket. Now I need to find the range. Remember, those are the y values. Is there a graph down here? No. What's the smallest y value I come across? It's right here, and it's at -4. Remember, open circle, it doesn't include -4. That means it gets infinitely close to -4, but never touches it. And then y values keep going up to here. And what's this y value here? It is +8. Is there a point where y equals 8? Yes, so I put a square bracket on it. So my range is parentheses -4, 8, square bracket. And now let's look at my last example. In this one, I have an arrow on the end. That means this graph is going to keep going up and to the left. So the domain of the x values, is there going to be a graph out here? Yes, that graph keeps going up and out to the left. So what value is down there in the x direction? It is negative infinity. So my domain is parentheses negative infinity. I have x values all the way through to this point here. And what's its x value? It is 0, because this is 0 in the x direction. And is there a point when x equals 0? Yes, right here. So I'm going to put a square bracket on it. So my domain is parentheses negative infinity, 0, square bracket. Range of the y values. There's no graph down here. What's the smallest y value I come across? Right there at 2. There's a point where y equals 2, so I'm going to put a square bracket on the 2, comma. Now what happens to this graph? It's going to keep going out and up. It's going to slowly get larger and larger in the y direction. So it's going to approach positive infinity in the y direction. So my range is square bracket 2, comma, positive infinity, parentheses.